Assalamualaikum and salam sejahtera. My name is Azizah binti TUKIMAN. I'm from Department of Civil Engineering, Polytechnic Port Dickson, Malaysia. Today, I would like to present our study for the title User Interaction and Perceived Effectiveness of S-VoC for Traffic Volume Count Studies. The content of my presentation today consists of the following. First, introduction. Second, literature review. Third, methodology. Then, finding and discussion. And the last one is conclusion and recommendation. Let me briefly explain the introduction of this research. Traffic study involves complex investigation and detailed analysis within a specific area's transportation system. In an era where smart technologies are rapidly transforming data collection methods, traffic monitoring systems have become more advanced and user-focused. S-VoC, or Smart Volume Counter of Traffic Flow, is one such innovation designed to streamline and enhance traffic volume count studies. This presentation aims to explore how users interact with the S-VoC system, evaluate its usability, and analyze how effective users perceive it to be in real-world traffic data collection scenarios. By studying these interactions and perceptions, we can gain insight into improving both the system functionality and its acceptance among practitioners. Okay, next, our problem statements. According to Gonzalez et al. 2019, traffic congestion remains a critical issue that must be addressed, as it leads to time delays, energy waste, environmental pollution, stress, and ultimately reduce society productivity. Now, the current methods of traffic counting face significant challenges that hinder their effectiveness in transportation planning and management. So you can see that the manual techniques are increasingly obsolete in the context of today's rapid technological advancement. Furthermore, data collected manually cannot be stored in digital database for further analysis. If such data is lost, there will be no reference for the traffic volume previously recorded. Let me explain the objectives of this study. First, to evaluate the user interaction and perceived effectiveness of the mobile application tools, which is electronic vehicle count (EVAC) and digital vehicle count (DVAC) for traffic volume count studies. Second, to determine traffic flow volume and intersection performance levels based on data measured in passenger car units, which is PCU. This is some our literature review that will support our study. Next, let me now walk you through the methodology. Okay, you can see overall a methodology flowchart. First, we are planning the determine tool of case study, which is EVAC and DVAC, and then we're making a literature review, and then brainstorming and suggestion for proposal design. After we accept our proposal design, we make a 3D drawing and produce a product, and then we make a case study at the designated intersections. Next, we make demonstration and distribute questionnaire to lecturers, student, and technical officer. So for this study, we use a quantitative research design with a questionnaire as a primary tool for data collection. The questionnaire was designed to evaluate user interaction, to evaluate and then to preserve effectiveness of the S-VoC system in supporting students during fieldwork and data observation session. A preliminary study was carried out also to evaluate the questionnaires' clarity, consistency, and validity prior to its full-scale implementation. So next, we make a demonstration, and then we make an analysis based on the data collection by SPSS, which is statistic software. And last one, after we get the data collection, we analyze and we discuss and make an improvement process. Okay, this is a S-VoC, which is electronic vehicle count interface. Okay, first we install and then register, and then we select the location via GPS, And then you can collect data, begins for left turn, right turn, straight or U-turn, and count the traffic flow. And after that, the data collection ends after 1 hour. And last, you can export the data into Excel, and the application will automatically convert the data into passenger car unit, which is PCU. Okay, next we can see S-VoC for DVEC, which is a digital vehicle count interface. Okay, the next section is a finding and discussion of this research. For achieve the objective number 1, which is the user interaction and perceived effectiveness of EVEC and DVEC for traffic volume counts, the survey findings and respondents' feedback were analyzed to assess how well the mobile application and digital device enhance the teaching and learning experience, as well as their overall impact on the highway and traffic engineering course. So from the chart, we can see that 92% of respondents agree that the EVEC and DVEC is highly innovative, effectively meets its intended purpose, and features a design suitable for use in a real field locations. And 91% agree that the product is user-friendly, easy to operate, clearly in demand within the market, and cost-effectively. And then we can see also that 90% of respondents felt that it delivers a positive impact for user. And the last one, we can see also 89% respondents agree that the product has strong market potential for both individual users and industries, and that the cost is appropriate in relation to its value. For the findings, to achieve the objective number 2, which is a traffic flow volume and intersection performance level based on data measure in PCU, we can see that for the both graph, PCU versus vehicle on weekdays and PCU versus vehicle and for weekends, we can see that car recorded the highest PCU values on both weekdays and weekends, followed by motorcycle based on peak hour traffic volume observation. And this innovation also has a capability to produce printed outputs, hard copy in the form of table, form, reports, or digital formats containing vehicle counts, data, and PCU information. Moreover, peak traffic flow pattern can be clearly identified, and students are able to interpret the most frequently occurring vehicle types passing through the intersection. This is a sample of vehicles recorded during an evening counting session. Lastly, for conclusion and recommendation, this innovation has received positive feedback and demonstrates strong potential for commercialization and marketability both within institutions of higher education and technical departments. Additionally, the product has proven to enhance employability to outcomes when compared to traditional manual methods. However, several improvements are recommended to further optimize its efficiency and functionality in the future, including first, enhance the system capability for real-time, simultaneous online data collection before data is printed or stored. And then the second one, upgrade the system by integrating solar power device for conducting on-site traffic volume counts. That's all for my presentation, and thank you.